last week we talked about Maxwell, and I'm going to go a bit further back, and we talk about Michael Faraday, who at one time was on the back of the £20 note, I think, £10 note, I don't remember. Very interesting person. And I mentioned Faraday because he was one of the first humble scientists, and he was an assistant to Humphrey Davy, so Humphrey Davy of the Miner's Lamp, who rather treated him as a, if I say a servant, that's the wrong idea. Because when you say a servant, you think, oh, somebody who chops the dishes, chops the vegetables and does the dishes and that sort of thing. It's more a household servant. So a big household would have servants. There'd be a tutor, for example, for the children, and perhaps a dancing master and so forth. So it's more that sort of tradition. And that caused some friction on them when they were traveling. But he was also worked in a bookseller. Anyway, I mention that because he kept a laboratory notebook, and I don't know what the history of laboratory notebooks is, but his is very highly regarded, and I suspect that it was probably a standout of his time for laboratory notebooks. So he recorded every day everything he did, and there's strong traditions relating to laboratory notebooks, which in later years became very important when he dealt with patent law, because the laboratory notebook provided proof, or at least evidence, that you made the discovery at the time you made it. It's got a strong evidentiary value. Now, Mathematica and I think Maple have these scientific notebooks, and this tradition has been carried on through the R community. So you have R notebooks, and there's also Jupyter notebooks, which developed out of Python, but accommodate other languages. And there's something really interesting about Jupyter notebooks is that there's a back end for Jupyter notebooks called Jupyter Hub. And there, it really is cloud computing. Jupyter Hub allows you to construct a virtual machine on the basis of a specification that's attached to the notebook. And then you can run the notebook entirely through the web browser, and the computational stuff is done on the cloud. So that's quite useful, and you can see why publishers are interested in that sort of thing. Because even if you're interested in reproducible research, a large part of publishing is allowing data to be visualized. If you go to Tufts, then Tufts' famous diagram, I don't know if it's due to Tufts or someone else, I think it's someone else, of the progress of the Grand Army of Napoleon to and from Moscow and the various diminutions that took place is an example that allows you to, so to speak, visualize things. And Florence Nightingale, as well as being a nurse, was a pioneer in statistics and a pioneer in the public communication of science, particularly in the nature of public health. And she invented with other people, various mechanisms for the communication and visualization of information. And when I say visualization, I don't necessarily mean seeing it with your eyes, but being able to, so to speak, see it with your mind. So if you've got a scientific paper that requires an understanding of a large amount of data, why not put the data in a spreadsheet, attach the spreadsheet to the journal article, and provide an exploratory tool for the data so that somebody can actually look at all the data, and if they want to, run their own queries on it. Of course, you could do much, much, much more interesting things if you have a live scientific notebook with a computational back end. So to begin with, the Jupyter Notebook was something you ran on your own machine with your own version of Python and everything else. And it became something that was no longer confined to your machine, but which was in its own right publishable. And the purpose of Docker, if you like, is to allow a virtual machine or something that does the same function as a virtual machine to be published. So here's the recipe for the virtual machine that you must do use for this calculation. And here's the calculation. And the work that I put in my email is a next step of that, which is that there's no back end. Everything's done in the browser. So clearly you can't do massive things there, but you can certainly publish small things, and it's quite good for education. So Mozilla and Jupyter, both of which are well funded, are doing work to produce a data science platform that will work on your machine, in the browser, and in a mixed version on the cloud, or perhaps even entirely on the cloud. So running everywhere doesn't mean on every machine, but on every platform. And the platforms include the cloud, the local machine, and the browser. The browser is another platform, just as the judge that ruled on the Microsoft case said this is what Microsoft is frightened of. I think at this point it's interesting to note that Microsoft has become a leading supplier in cloud computing. People tend to speak quite highly of it. And they've also become a big supporter of open source, in that there's a Linux system subsystem for Windows, and they have taken over GitHub without at this point doing any harm to its structure. So let's go back. There are these strong forces, Mozilla, Jupyter, are strong representatives. If you want to broaden it out, it's everybody that fought for the standardization of HTML into HTML5, so that web browsers did the same thing, even when you went to the quirks. So all the people that made the web browser a platform, which was work that took place, perhaps, I'm guessing here, 15 to 5 years ago, the HTML5, all that work has now made it a very good platform. Not a very good platform, but it makes it a reliable platform, so that you don't have to forever test everything on all sorts of different machines. So that's the force outside the control of the tech users group. And if they need mathematical typography in their scientific notebooks, they will put it in.